Alright, you are welcome to this lesson, and in this video we also have to find the dy dx of these functions. The first one is y is equal to x to the power of sine x, then multiply by ln x, and the second one is x to the power of x. So far we have been dealing, this is the first question, this is the second one, and so far we have been dealing with variables to the constant problem. So in this video you observe that this problem is a variable to another variable problem. So how do we solve such a problem? So firstly, let us take this first one and see. Taking the second one, second problem, let's take that and see, because it's simpler than this. So if you can understand with this question, then you should get this one as well. So let's do this. The first one is y is equal to x to the power of another x here. So what you should do here when you see a problem like this is that you take the ln of both sides. That's the first thing you should do. You take the ln of both sides. Ln stands for natural log. So you take both sides of ln. So you have ln y is equal to ln x to the power of x. Why did we do this? Why did we make this move? We made this move because the power here is really disturbing. But the law of logarithm, the law of log says that we can bring down the power by, we can bring back the power here. So by applying log to both sides, I can bring this power down here and it becomes x ln x. So the idea is just to bring down this power, because without that we can't solve this problem. So what you should do, the first thing you do is take ln of both sides. After you do that, then you can apply one of the properties of logarithm that says that when you have log of a to the power of b and base of c, it says that this b you are seeing here can come back here and become b log of a base of c. Now this is what will happen. So in this case as well, after applying ln, this x can come down to b to multiply the ln function. So after that we can solve our problem. So here will become ln y is equal to x ln x, right? Yes, sure. So here we can apply our product rule. But you see something here, the function has changed from y to ln y, and because of this function will apply what we call implicit differentiation to this part here. So we get our clear function. So here, don't forget, your function is a function that depends on x here. So we have to differentiate with respect to x, right? Don't forget. So here becomes 1 all over y dy all over dx. Yes, because what you just differentiated is y, and you are doing so with respect to x here. So, and you know ln x will give us 1 over x, and ln y should also give us 1 all over y. So here, by applying our product rule, we can pick, product says that differentiate the first function and keep the second one, add the result to keep the first function and differentiate the second function, because this is two functions multiplying each other. So let us apply that rule here. Now what's f of x? F of x here is simply x, the first function, and g of x here will be the second function. Now if this is f of x, it implies that f prime of x is 1, and g prime of x will be equal to 1 all over x. This is what you get when you differentiate ln x. You get 1 all over x by the formula u prime all over u. So we can apply our product rule here. So we have 1 all over y dy all over dx is equal to f prime is 1 multiplied by g of x will not change, ln x, plus f of x is x and g prime is 1 all over x. So let's simplify this, cancel out this. So we have 1 all over y dy all over dx is equal to ln x plus 1 1. And you see we have y here, dy dx. So what we need here is dy dx. So we multiply both sides by y, by y, by y. So here we have y cancel out y, and finally dy dx will be equal to, this is y here, this is y here, ln x plus 1. This is our y. Now what is the y to begin with? Our y was x to the power of x, so we replace that here by saying x to the power of x. Now this is the result after we differentiate y is equal to x to the power of x. Now for the first problem here, you will be solving that in the next video. Thank you, and see you in the next lesson. Don't forget to like and subscribe to our channel.